Welcome back to the See It in Action demo series. Okay, for this demo, I am going to demonstrate a migration from an on-premises SQL server running on VMware to AWS with the boot drive going to the Amazon Elastic Block Store, and the data drive is going to Dell PowerFlex without performing two phases of migration. This is the environment. I have a Windows 2016 machine here with a VMware server. It is running a SQL server. On the local host machine, I have a birthday test database that is running. This is our AWS account. And for this demo, we are migrating to Ohio, which is in US East 2. In this particular demo account, I have already prepared our 3-node PowerFlex. On the PowerFlex user interface, we can find the same matching nodes. We currently do not have any configured volumes, and just an SDC registered for something else. There is a storage pool named SP01 and 3 SDS servers. And I will soon be migrating our server into this AWS account with the data drives to the PowerFlex. Let's go to Cirrus Data Cloud. This on-prem to AWS compute migration is the project that I'm using for this demo. Then I am going to deploy Cirrus Migrate Cloud on my host by copying the installation command and pasting it in the shell. CMC will install and register to Cirrus Data Cloud all by itself. My Windows 2016 123 host is now displayed on the registered host list, meaning that the installation is completed. And here are the 3 devices that I am going to migrate: the 25 gigabyte boot drive, a 2 gigabyte SQL data volume, and a 953 megabyte log drive, the CD and L drive. We can confirm it here from the machine: the C drive, D drive, and L drive. And these are all VMware local disks, and it can be any type of disks. Before I continue to show you the next step, which is to set up the integrations, let's briefly look at MigrateOps. That is a purpose-built data mobility as code automation platform that is designed to make data migration in enterprise scale easier, safer, and more predictable. Here, I want to show you the MigrateOps reference, where there are purpose-built recipes for all the scenarios you need. I'm going to use this compute migration to AWS recipe for this demo. From here, you can see all the options, including availability zone, network configurations for what network am I using, VPC, and all these settings. Then we have cutover options and destination storage configurations. But one particular option I would like to point out is the PowerFlex data storage. This makes it possible for me to migrate my data volumes to Dell PowerFlex directly. All I need is to specify the MDM IP and which connections to use. And now is the time to go and set up the integrations for the next step of this demo. I am first setting up the AWS integration for migrating the boot drive and creating the VM. Next, I am also setting up the Dell PowerFlex auto-allocation integration so that we can allocate our volumes dynamically. After it's done, I have named them the AWS demo account and PFlex AWS. Now that I have the integrations and the host ready, let's move on to create a new MigrateOps recipe, as I previously mentioned. Click on Start New Operation, and this will open up an editor window where we can enter the configuration. Like many other industry-standard automation tools, this configuration is in YAML syntax. Let me bring up an editor to show you how simple it is to create a brand new YAML file configuration. Also, I even have the GitHub Copilot enabled so that we can enlist the use of generative AI to assist us on building this configuration. All right, let's start with the operation name, which is Windows 2016 SQL Server to AWS. And, oh, wow. The AI has already suggested a lot of different things. Let me just take the suggestions and continue working on it. And of course, while I am creating the configuration, I can always come back to the MigrateOps reference to apply all the fields we need. Back to my editor, the AI doesn't know what the connection IP it is for the PowerFlex data storage. Now I can come to the EC2 instance and get the address, then type it in the editor. There are tons of generative AI tools that can help us create the configuration. And what I have here from GitHub Copilot is most likely learned from the Ansible playbook I previously did for this environment. Let's review what the AI suggested. We have decided to go with the US East 2 for the region, a T3 medium instance type, and this is going to be the availability zone. We also have the VPC and subnet selected, where if I come to the VPC on my AWS account, I can find the default VPC here. And I am going with this 2B subnet. Next, I have to add the storage and volume type, which once again, the AI has done it for me. Then the same thing goes for migration and cutover. Let's check what it has done for me on cutover. The AI has suggested to stop application, then to stop service for my SQL. Again, the AI knows all these, since this is already on the inventory through our previous work with other Terraform Ansible playbook. So this basically created a cutover procedure for me. In Cirrus Data Cloud, we provide extensive cutover steps that I can easily incorporate. Say before I cut over and I want a consistent image, I will have to stop the application, and a lot more that I can do just by looking at this. Or I can even put in a shell command to perform various actions, just like what I have here. Now I believe this is ready. Note that this is just for one host. You can add as many hosts as you want into your configuration, but for now, let's keep it simple and submit this configuration for this demo. Let's paste this into the configuration editor window and create the operation. The migration operation has started. Once I enter this newly created operation, I can view all the details. This is going quickly. The operation has already prepared the source host PowerFlex SDC, created the network interfaces in the AWS account, and it has already identified the subnet, the AMI to be used, which I will be using for final cutover. And coming back to AWS, a T3 medium instance has already been created. As MigrateOps is going through all the tasks, it is now creating the image to start the data copy. Moving on, my new CMC destination AWS EC2 instance has been deployed. If I go to the registered host list, a new MigrateOps appliance is already added. And yes, we have created the H2H connection, prepared the destination Dell PowerFlex storage, and we have prepared the destination EBS storage. So let's take a look at it. Under storage, there is a 25 gigabyte volume for the boot drive, the same as my source boot drive. As for the data drives, the two new disks were already created in the PowerFlex. However, both of the sizes are an 8 gigabyte, since that is the minimum size of PowerFlex volume. Because the integration I set up earlier knows that even if the original size is smaller than that, we have got all the requirements covered. An SDC is also created, which is a Linux type with the 2 volumes assigned to it already. Coming back to my operation on Cirrus Data Cloud, the EBS storage volumes were created, and a migration session is also created. I can come here and check out the migration session. This is just like any of our normal migration session. It is now synchronizing. My 25 gigabyte C drive is now migrating to the new Amazon EBS, and our D drive and L drive data volumes are migrating to Dell PowerFlex. We can track the progress with the change data map. The dirty blocks here show that this is a live migration. We can see the live migration I/O performance. Here's the thin data ratio, alongside up all other migration information we need. Oh, apparently my data volumes have already completed the synchronization. And all this time, the drives are still live. The SQL database is still up. Any changes that we are making will accumulate here into the data. Now, let's just wait for the synchronization to complete. Back to the operation, our data is synchronized, and I am ready to cut over. Once I approve it, the source system will be powered off, and the new AWS EC2 instance will be powered on. Upon reaching this stage, we will receive an email notification, and we can come here to set up an approval window if we decide to start cutover later. But let me just approve it right now for the demo. Once approved, the operation will proceed the rest of the steps. Meanwhile, in AWS, we can see that the data has been attached here, and the overall performance is revealed on PowerFlex since we were just migrating to it. The operation has proceeded further. We have stopped the application because everything is synchronized. Now, I have this migration report generated where I can always come back to the reports and view all the detailed information about this migration, and I can show my boss this report. We have powered off the source system, and it is now reconfiguring. Our MigrateOps machine is stopped, and we are performing the final cutover. Cirrus Data Cloud will automatically create the final production instance. It is doing its final reboot. This is marked as a Windows 2016 server. The SDC is no longer connected because it is off during the final cutover. In a brief moment, everything turns green. That means my operation is completed. Let me check the EC2 instance again. Our MigrateOps machine has been terminated, and the new instance is running with a 25 gigabyte boot drive, just like the original source. It's booted up and running. Coming back to the PowerFlex, my SDC is Windows 2016-123, which is automatically created. And this is the IP address. 2 volumes are mapped to this, which is my 2 new 8 gigabyte devices. Let me connect to it on the remote desktop. Perfect. From the computer management, my new 25 gigabyte boot drive is running as the Amazon Elastic Block Store. My new 8 gigabyte data drives are running as Dell PowerFlex. It's all automatically connected back, and everything is migrated successfully. When I open the data drive, the data is the birthday database. It is now a Microsoft Windows Server 2016 Amazon EC2 T3 Medium instance. When I connect back and open the birthday database, and yes, all our records are migrated successfully. And this concludes the demo. Let's have a summary of what I did. First, I installed CMC on my host and set up all the integrations I needed for the migration, which were the AWS Public Cloud and the Dell PowerFlex Auto Allocation integration. Once I did this, I proceeded to create a migration operation configuration in YAML syntax with the assistance of a generative AI tool and Cirrus Data Cloud's MigrateOps reference. Once the operation is started, all the necessary migration and cutover tasks were automatically completed upon confirmation. This is how you complete a migration with the boot drive going to the Amazon Elastic Block Store and the data drives going to Dell PowerFlex. Thank you.